Our next speaker is Jonathon Ralston. Jonathon is with the CSIRO. He's the head of the integrated mining stream and has had a focus in coal mining. Welcome, Jonathon.
Thanks very much. Thank you, and good afternoon, everybody. Delighted to be here. I'll press the button and make this happen, if I can. No. One button. Green? Green button, they told me. Today I want to talk about how we might be casting mining into the digital. I think there's a quote from the guy who, big time in Yahoo, said, if we can cast our problems into the digital, then we can hop onto Moore's law and capture the benefits from that. And a lot of the things that we do in mining is around mining automation, and certainly that's really all about information and data. I'm going to try my best to try and weave a story about pigeons into my speech, but I was thinking in coal mine traditionally you had a canary, so that's a slightly fancier version of a pigeon story. So thank you. That's cue for laughter. I'm with the CSIRO. CSIRO is about 5,500 people around Australia, and really we're interested in taking science and having impact in industry. The particular area that I'm involved in is mining, and I'd just love to see, has anybody been to an underground coal mine before? Gone underground? Fantastic. Well, you'll know about this. Often we describe mining as the 4 Ds: dirty, dull, dangerous and difficult. Dirty, as you can see here, this is a very, very large mining machine known as a longwall shearer. I've spent a bit of my life working with this particular piece of equipment. As you can see, maybe just in the back there, a person is actually operating that machine. So the first thing you note is it's dusty and could be quite dangerous as well. Dull. On the left-hand side here is a mining machine. It's actually called it's cutting the floor. And these other trucks here are basically waiting to be loaded. I was on one of those, it's a Cat 789, very, very exciting for about 20 minutes. But if you're sitting in a queue for an hour and a half, it gets kind of boring. So here's an issue where mining can actually at times be incredibly dull. Dangerous, still the philosophy within the Australian industry anyway, is if there's an issue, self-rescue is probably the best way for you to survive. And in fact, I think the statistics are when they send people in to try and help, it's normally not net positive. So again, the Australian coal mining industry has been safer than ever. In fact, that's probably a bit of a challenge. It's maybe so safe that it's even a challenge to keep it economic at times, but it at times can be dangerous. I mean, most of you probably don't go to work thinking the roof could fall on me today, I could get run over today. It's, not quite like that. And finally, difficult. One of the key underground coal mining aspects, you're basically creating lanes and streets underground. You have to constantly install ventilation for people. And here's 5 guys. Nominally, this should only take a moment or two, but here's 4 or 5 people having to actually install a tube bundle to make sure that there's fresh air at the cutting face. And it can just be plain difficult. So our approach to that is really looking at how can we increase the level of automation. And that's really the driver for us. A big key that comes from our industry at the moment, and this is a beautiful thing, I'll pop them all out. When we've spoken about it, I think in all the presentations we've had today, the call is now is the time for innovation and change. And we need to change the configuration, which is almost a mindset. That's a cultural shift. And we mentioned this morning, you need a champion who both understands the technology. MineSight must be their first language, but they must be also able to speak technology to bridge the gap. And need a partnership to see that change. And that's really something that drives us, and it's a very, very compelling statement for us. In terms of automation, these are the components that we see. There's really 3 key elements that are needed to create automation. At the bottom here, you have your mining process. The first thing you need to do when you're operating is have an awareness of the operating environment. That's really sensing, so there's a sensing problem. Use that sensing information to then make a decision. You process that. Ultimately, you provide a machine to then action that. That then changes the world and the loop continues. The interesting thing is, if you don't have technology for sensing, processing and trusted autonomy, a person needs to do it, and they need to do it in real time. So at the moment, there's a person at the heart of that closed loop control loop. With IoT, some of the challenges are you press a button, and a few seconds later you might have a response. A lot of the systems, particularly with automation and control, you've got a few milliseconds to make a decision about where to place the mining instrument. So you need, at the moment, people to be fulfilling components in there. What we really want to be able to do is have higher levels of technology for each of those three components so that we can place a person outside of that loop, so it really then becomes information driven. And that's about the digital component. That's where we want to see it go. Once we have that information, we're then talking about true digital mining. I want to quickly give you a use case, how it is different in mining. I guess sometimes with IoT, we can think about a mass deployment of many small low-cost modules being distributed, being utilised by people on their mobile phones. Mining is a different game in some ways. You have large pieces of equipment that might be $50 or $100 million each, and so there isn't just the scale. So how does it actually work in a sort of mining context? Just want to show you what we have done so far with automation, and then to see where we can plug into the evolution in IoT. The machine you saw earlier, longwall shearer, effectively dust is there. That great big long line there you see should be a straight line. The other thing is there's a person there who's not only controlling a ranging arm drum, which is probably 2 or 3 meters high, he's also trying to navigate. The direction of mining is in fact to your right. So he's actually slicing coal backwards and forwards with these other guys here. An incredibly difficult job. One of his biggest problems is not actually knowing accurately the location of that piece of equipment. So this is what we need to see. Nobody there, completely straight, computer driven. One of the things we did was took a high-end inertial navigation system. We embedded that in the body of the shearer itself. From there, we were able to generate 3D visualizations at a remote location, providing information. Suddenly, we're able to archive the path and the progression of the equipment itself and further on. And finally, then that provided the genesis for an integrated model. But really the core of it was sensing. Once we had that sensing component in a digital form, it then enabled a whole bunch of other technologies to come in. And it can be operated remotely using sort of exciting VR and AR experiences if necessary. That's the kind of sort of state of the art in underground coal mining automation. But where can we go from here? Another component of that, we might know where the machine is, but really it's very important to know where the geology is, so you can actually center the machine with respect to the host geology. This is a camera that is approved for use in an underground coal mine. I'll come to it later, but there's some special requirements to actually have equipment working in an underground coal mine. So the idea is, to the left here you see a pretty much off-the-shelf camera having to be enclosed in maybe a 10 or 15 kilogram enclosure. It's called a flame-proof enclosure. The concept is it's not to protect the equipment, it's to protect the rest of the world if the equipment fails. If it has to operate in a methane-rich environment, it could cause an explosion. So equipment is really hard to get underground. But here's one system here. The idea being that if we can utilise this type of technology, camera technology, you can utilise natural features that are apparent in the geology. In this case, it's a marker band, to use that as a datum for horizon control. So we had a whole array of them, which is probably our first go at the Internet of Things. It's kind of looking at things at scale, bringing those things together to provide a complete face picture. Exciting, interesting. The most important thing for the customer is, well, what's the impact, what's the value? This particular innovation is known as LASK automation, really has had some great benefits to the industry, high uptake. Probably one of its biggest things is minimising transaction cost and downtime. It's been accessible. One of our big areas was about making it open and accessible. And finally, the return on investment to that is then enabling further development. If you want to see more details, I'm just skipping through this because I want to get to the IoT bit. There's the details there. So IoT for mining, where are we today? It's hard to get information technology into some sectors. This is from Deloitte in 2012, but I think it still holds true. This graph shows how quickly an IT-based innovation can have impact in a particular area, and the magnitude of that impact. Really what you'd want is, short fuse, big bang. Didn't take long, made a big difference. If you look on this left-hand side, you can see the sectors which can most rapidly take, digital technology. And they're things that are often virtual in nature. They're on a screen, they're information that be provided on a mobile phone and so on. If you go further to manufacturing mining, which is mining's just there, it actually has more difficulty utilising, or takes longer to actually realise the impact of any innovation. And part of that, the reason is both mining and manufacturing have to actually deliver something. It has to be a tangible product, whereas many of the other components are actually really information or advice that then you, the customer, then utilise. So there's a practical, pragmatic aspect as to why sometimes it's difficult to get real impact in these particular sectors, because you actually have to produce, pork barrels at the end of the day. Some challenges also in mining, which are really, really important. I guess some of the operational requirements have to be much, much higher than what you'd perhaps normally expect in other applications. It has to be physically robust so that it can actually live in the environment that it has to operate. Huge issues to do with compliance regulations. The hardware inside is actually a fraction of the cost that it takes to actually get that equipment in place. Not only that, has to be in a form factor that's actually easily deployable, so everything has to be taken down, it has to be installed, has to be ideally installed by an individual, so there's 15 kilogram weight limits and so on. The lower the maintenance, a failure is sort of not a good thing. If, for example, the piece of equipment falls off, it becomes what is known as a reportable incident. They will close the mine until an inspector has come down and made sure that the system is all running smoothly, and it may be $100,000 or $200,000 an hour operation. That's a big deal. So that just is going to create a barrier for the introduction of new technology, and really high performance is huge in terms of it getting accepted. Some practical pictures. If I could put a sensor, let's call it IoT, where would you want it? Right here would be good. That's actually what's known as a support that keeps the roof from falling on top of you. So there's no power. It's physically a difficult area to mount equipment. It has to be inspected every single day to make sure that the flame paths are correct. So that's just tricky. Other places where it needs to operate, just physically difficult and robust. Has to operate in areas such as this, which are completely occluded with dust and so on. So it's a challenging environment that the equipment needs to go into. We talk about IoT and networking, and we can do things wirelessly. If you want to do anything in the real world, at some stage this has to connect to reality. That means wires. Yeah. So this was a wireless network, but ultimately that actually had to control a whole series of actuators. So at some stage, if you really want it to have impact, it's got to go through something like this. So that's just a practical reality as well. If you want to use Wi-Fi in these environments, you can't just walk down with your mobile phone. You have to go through a whole range of extra processes. Those little two shiny boxes, there's a company here in Sydney who will happily sell you them at a couple of $1,000s each. They're approved. They let you use your Wi-Fi externally because they have a capacitor and an inductor in there that's been approved for use. So it just makes everything that extra bit more difficult. What are the other, I guess, these very practical challenges for IoT and mining? The immaturity of the whole industry means chaos. There's some people who love it, champions. Others are concerned about what does it all mean. Interoperability, a lot of these things you've heard over the last day and a half. Management, who owns the data? How do we utilise it? Mentioned earlier about mining companies actually do collect a lot of information. Most of it sits on a hard drive somewhere, unanalysed. Issues about power, landscape. We go from IoT devices like this to this is an ecosystem picture as of 2016. So if you're talking to your customers, there's individual companies there and there's Google there, and they're all represented by a little blob. So the ecosystem's a big place and so can be confusing. Opportunities. The industry is recognising that it is actually increasingly becoming an information-driven, closed-loop operation. So we really want to see the loop closed. And at the moment, most of it's find it, mine it, off you go. But we want to see some provenance across the whole value chain. Looking at how we see this information, how we distribute it well, how we have automation that is actually at high integrity, and to that, sensing is critical. A lot of the processing components and display components kind of already exist, but really sensing is key to all of that. A quick one, if any of you heard of the book, The Sixth Wave, what are things that are going to drive this innovation? Really, it's a fantastic book written by a guy who used to work for CSIRO. I think the biggest one, he wrote this back in 2009, which at the time, now you read it and say, oh yeah, that's obvious, but he was talking about we are increasingly moving into a resource-limited world, and we're going to see this increased movement to resource-oriented delivery. So I guess in the things we're talking about IoT, it's really democratizing and the whole service provision. So it's really about minimising transaction cost, which is a kind of optimisation ultimately. Just before I conclude, I'd love to chat with you. CSIRO is actually exploring what does IoT mean, not just for mining, but within energy and the broader organisation. We're involved in the IIC, the Industrial Internet Consortium, trying to understand how we direct that. We're part of a mining task group. If that's of interest to you, please talk to me. CSIRO has an IoT blog, which talks about a whole range of applications. Have a look at that. And I'd be happy to connect you with anybody within CSIRO if there's something of interest to you. So IoT really is that bridge, I think, connecting digital to physical. I think mining is slowly realising the value, and so there's big opportunities for everybody to be engaged. Thanks very much.